So our next speaker is on something very interesting with regards to renewable energies, WaveHexaPod. Johan Paulides is the speaker. Let's welcome Johan.
Thank you very much. I heard today that they got their inspiration at the conference. I also got my inspiration at the conference, to be honest. But before that, I got my inspiration at my grandfather. So at 2 years old, I was sitting and watching my grandfather wind by himself electrical motors. And we always say, and don't take it wrongly, a robot is an electric motor with an arm. Yeah. So this is WaveHexaPod. WaveHexaPod, we are trying to do the reverse. We do everything the other way around. Yeah. So instead of robotics that actually moves something, we want something that moves to move the robot and to generate energy. So this is what I'm trying to present here today. Today is how are we using robotics actually to generate energy from waves. I'm Johan Paulides from the AES Group. I'm the owner, third generation of a family company. We are situated in 7 locations in the Netherlands nowadays, 3 locations in Europe and 3 locations also in the world, US and India. And we have also an Indian plant. And today we talk about one of our applications, which is the WaveHexaPod. Our mission with the WaveHexaPod is to provide energy to you. Because today was a good day actually. Today we had sun and wind. So it was a very good day. But usually sometimes we don't have sun and we don't have wind. What's then the renewable? So we can solve it with batteries, but we have another sustainable source, and it's the last untapped sustainable source at this moment still worldwide, which is waves. And of course also tidal, but we are in waves. So we want to capture this wave motion and transform it into electricity. And this wave motion is not just an up and down motion like you feel when you are on a ship, but it's actually very multidimensional. And in order to capture this very multidimensional movement, we actually created a hexapod system, like a Stewart-Gogg system. So that's what you see here. And we started with this on the left. Traditional Stewart-Gogg platform, robotics platform, but quickly realized that the actuators, first of all, usually are hydraulic, if they are that big, because we need about a stroke of about 7.5 meters. So it's not that small, in order to capture the waves. And they are quite expensive. So we need about 6 of them. Well, if we talk about hundreds of thousands of euros, it becomes a very expensive device. So then we got across at the trade show, and we saw second-hand automotive robotics. So we said, why not use that? Why not circulate, because that's also what we are all about, recirculating materials. Why not use old robots that lost their accuracy in the automotive in order to capture energy? So we wrote a number of patents, and here you see in the zoomed area, you see the 6 robots that are on top, that are connected to 3 buoys, and those 3 buoys are a fixed platform, and rather than just capturing the up and down movement of the sea, they actually capture the surface energy. And the surface energy is a very interesting energy to work with. So here you see generating energy from a robot should be very simple. We do a tug of war. It's very simple. Actually, it's not so simple. Because immediately we got into all kind of errors. And immediately we work together with ABB very closely, ABB Benelux, but also ABB in Vastras, the research center. They said, oh, be careful, be careful. You need to be compliant. So luckily, we knew a little bit what compliant was, and we put something plastic in between in order to be compliant. And we had 2 people pressing the button in order to show that it's possible to have 2 robots that move together. The next stage was to actually show that we can harvest energy. So how did we show this? We call it a robot. It's like rowing, like that. So this is what the robot is doing, both of them. But while it's doing like that, the other one is pulling. So it's actually pulling the one that is at the back. So at this moment, it's pulling. Again, we had to be compliant. So again, we had to put some ropes, or what do you call it, strapping material. We had to put in between the robots in order to show this. ABB said, oh, don't do it. Yeah, it's not safe. Yeah, So luckily we have a test facility where we are not so close, yeah, and we have a big base at the bottom, yeah. So at least it's firmly welded to the floor, yeah, and finally they agreed with us, and they also help us. They're sitting here, yeah, and we showed that yes, we can harvest energy. So then we went to Vasteras, to the research center, and they said, very well, you are the first to come and ask us this question. So there are so many bright minds here, please assist us. Because in the literature, there's very little information about robotics that generate energy. Actually, the only thing that is currently done in industry, but also I think in research, as far as I can find, is that we reuse the brake energy. Yeah, so that we accelerate, and while we brake, we move the energy back into the battery. That's currently the status. So, okay, we also said, can we put the robots upside down? Well, of course, not allowed, but we are industry, so we just do it, and we show, yes, it can be moved. As soon as you put them soft robotics, it falls to the ground, so be careful. And then lastly, so we build the complete setup, because in the WaveHexaPod, of course, the robots are gravity compensated. Because we have a buoy that is buoyant, and then, of course, the robot doesn't have to hold its own mass. So we made a system that can actually mimic that, with a big mass, big concrete mass that goes up and down. You see it in the middle. But then comes the hard part, because then we need intelligence. And luckily, we went to Stefano, and also with the students. We mimicked, and you see it on the right, we are trying to mimic this behavior. And it's quite complex. It's quite a complex challenge. So we hope that we inspired you. We can do brownfields, greenfields. I can do the business pitch. I did the technical pitch a little bit more than the business pitch. But be convinced, we are the best. So don't worry. We can solve the world's problems. Don't worry. It will be done. And also we cannot do this without our partners. So we have a lot of partners that we work together with. But most of all, we are doing it for our own pockets. So we are paying for this. So when you are paying for it, you think twice about putting a robot upside down, because it's 50,000 euros. If it falls down, it's gone. But anyhow, thank you very much for your attention. I hope I inspired you. Thank you.
That was both very interesting and very entertaining. Any questions? Over there.
Hi, thank you. So compared to, most wave generators are just the 1 degree of freedom. So I'm really curious, when you have 6 degrees of freedom, do you have any, at least simulation or even real test data to show how much more efficient you can be per square meter?
Yeah. So we work together with, in this respect, we work together with TU Delft, with the wave experts. And we showed that if we do the surface, we can almost square the energy. So it really depends a little bit, because the difficulty with the circular motion, I cannot go in all the details, but is that you're not a completely generating action. You actually have to kick the buoy back. Otherwise it ends up on the shore. So if you just let the buoy go, then slowly it will move, but it moves to the shore. So every time you have to give it a little kick. So a little kick back into its own initial position. So it's not just harvesting energy, it's also that you have to give it a small kick. So it's more complicated, but yes, we say at this moment you can about square the energy that is normally done only in the up and down motion.
All right, let's thank Johan again.
Okay, thank you.